while she was in Vegas. All right, so make sure you have a calculator. It was a long weekend. Can someone remind me where we left off? Yes?
Becky's becoming poor.
She's becoming poor. So we finished number 1. We talked about what that meant. The negative $6 is not how much she lost. What did we say that represented? How much she has. So she lost everything she started with, and now she lost more because she has negative amount of money. Okay, kind of a tricky understanding conceptual problem there. All right, let's go ahead and check out 2. What does B of t equal 80 mean? Again, we're talking about a 7-day layover and how much money she has. Can we think about input-output function notation? What are we trying to figure out? Yeah.
At what time she had $80.
What time, bless you,
Plus.
what time did she have $80? So during her 1-day layover, at what hour mark did she have $80? How can we use this equation to help us set up something we can use to help us answer that? You want to keep going? Yeah.
You could put 80 in for B of t.
And set it equal to the rest of it. Okay, if we're trying to figure out a time, what time, then the t variable should be left over. That's what we're going to try to figure out. Okay, so if this was a nice linear equation, we could solve for t. Unfortunately, it's quartic. Okay, it has that power of 4. So we're going to go ahead and utilize our graphing calculator to help us try to figure out this time value. Okay, we're going to go ahead and graph this so we can get a good visual. Let's go have a refresher from Friday. Where can we go to graph? Might have to look back. Yeah.
The y equals button.
Y equals. Okay. Now, the equation is already conveniently typed in on my calculator because we had to do this problem in first period. If you have anything typed in there that's different, you can go ahead and clear it out. But maybe in Y1, we'll go ahead and type in the function. Okay, that's representing the right-hand side of this equation. All right, just as a refresher again, the X button is right next to alpha, that green button. What else do we need to type in? You're on a roll. I'm going to give you a break. Go ahead, Olivia. Y2 is 80. Okay, we're trying to figure out where these two equations are equal, meaning where they're exactly the same. So it might be beneficial for us to graph the other one as well. Okay. Before we hit graph, what else should we do? Go ahead, Elsie. Look at the window. All right, now, again, from first period, this is what we kind of talked about and developed for our window. The window is what you want to be able to see of this graph. So how far left and right do you want to be able to see? Okay, we said this was a 1-day layover, so 0 to 24 hours might make sense. And then the Y values are representing how much money she has. Okay, we realized from number 1 that she could have negative, so we just guessed negative 10. And we don't really know how much money she might make, so we guessed 280. But we can always go back and change that if we have to. And if you're going from negative 10 to 280, we'll probably count by 20s. Okay, so with the equation in our calculator and the window set, if they're all the same, the moment we hit graph, we should all have the same picture. Okay, make sure yours matches. If it doesn't, you need to let me know. Yeah. I like those color ones so you can see the difference. Anybody else in the calculator help? All right, where should we be looking on this picture to help us find our solution? Yeah.
At y equals 80 at the intersection.
The intersection point. All right, we're going to try to figure out where they cross, where are they equal to each other? Okay, where they're exactly the same. Can we look back? How do we find an intersection on our calculator? More buttons. Hopefully it's going to become muscle memory though. Travis, you have an idea? Yeah.
You go second trace.
Okay, second trace. That's going to bring up the calculate menu. This is kind of our go-to menu page for anything we might want to find. Do you want to keep going?
And then you hit 5.
Okay, hit 5 or scroll down to 5 and hit enter. So far so good. We're almost there. Can someone pick up where Travis left off? He helped us get started. We got to finish it though. Go, Julia? Yeah.
You use the arrow keys to move it up so the little spider thing.
Mhm.
Put it right where it is.
Okay. Use the arrows to move the cursor or spider as close as you can to where you think it is. And go, Grace.
Hit enter 3 times.
Enter 3 times. 1, 2, 3. All right. After that, you should see the word intersection come up on your screen. So the ordered pair underneath it is the exact crossing, okay, where they're equal to each other. So we said that we're trying to figure out a time, which was like an x value in our equation. So it looks like 11.18-ish. Bless you. 11.18, comma 80. All right, so we'll say time is roughly 11.18. So a little after the 11th hour, she had $80. Coming back from Friday? Okay. Let's go ahead and check out 3. What does the y-intercept mean? Yeah.
I was just gonna.
Or question.
About this calculator.
Yeah.
I have doing the exact same stuff as mine,
Mhm.
but every time when you go to graph, it just gives you a syntax error.
It might be how you type something in. Okay. So that negative sign up front, I believe you hit that
I don't
button.
know.
It has to be up front. Yep. So that should
I
work
didn't
out
catch
better.
that.
I guess I do.
Yep. Yep.
That does work.
Syntax means you just type something in wrong. So go
I was
back
trying
and
to
check.
look I couldn't find it.
Couldn't find it. Yep. All right, let's check out 3. What does the y-intercept mean? We have a visual. Okay, we know the y-intercept is right there, but in terms of this scenario, what does that point represent? Go ahead, Julia.
Or starting amount of money.
Starting amount of money. All right, so y-intercept, how much she started with. Okay, and we're going to try to figure it out. So either by looking at your graph, or maybe some of us can just look at the equation, can we find how much she started with? What do you think, Olivia? 180. How'd you know? It's at the end. Okay, so just like in slope-intercept form, the plus b on the end, that's your y-intercept. That same idea is kind of happening here. It's the number on the end without a variable. That's normally, in most cases, okay, in most cases, that's your y-intercept. If you wanted to look at your graph, the y-intercept happens at an x value of 0. Like before anything starts, this is where your graph is located. So if you wanted to, you could hit the trace button and just type in 0. Your calculator will automatically let that represent an x value. And if you hit enter, it'll move the spider to that spot. And it'll give you the ordered pair at the bottom. This is a really easy and quick way to find values because I can hit trace and then 5 and know exactly what it is. I can hit trace and then 2 and know exactly what the ordered pair is. So instead of having to type in everything on your calculator's kind of home page to figure out a value, sometimes a graph is a little bit more quicker. So not only do you have a picture, but you have a quicker way to figure out values. Okay, nice thing to know. What about the x-intercept? Can we figure out what that point means? Okay, something right there that we'll try to find. What do you think, Blair? Yeah.
It's like when she had no money left.
When there is $0. Okay? Basically, how long did it take her to lose everything? And we're going to try to estimate that. Okay? Now, on your calculator, let's go ahead and hit the trace button. And we'll move the little spider cursor dude until we get really close to the x-intercept. Okay? Now, an x-intercept has a y value of 0, so you can take a look at the ordered pairs down below. If you try to get as close to 0 as possible, notice how it's not really going to get very close. At one point, I have 22.6, and at the very next point, I have negative 6.7. Okay, so with the particular window that we have in there, this is as close to 0 as we can get. So our actual x-intercept is probably something between 11.7 and 12. Do you guys have the same numbers on your calculator too? Okay, hopefully because we all have the same thing typed in. So just as an estimate, you can pick anything you want between 11.7 and 12. Maybe we'll say 11.8. There is a way for your calculator to find the x-intercept exactly, okay, very similar to how we find intersection points, but we're going to get into that kind of later this year. Okay, for right now, we'll just estimate. Is that okay with us, using the spider? Okay. All right, let's check out 4. What is the most money that Becky had? We have a visual. Where should we be looking? Maybe we're already doing it. I see pencils writing and fingers typing, so you guys are probably doing it. You have an idea, Blair? Yeah.
Top row.
Very top. All right, we're going to try to find our maximum. Okay, we wrote down the steps on Friday. Can we go back and use them? How can we find a max? What buttons? Go ahead, Caitlin. Yeah.
Second trace and then go down to number 4.
Number 4. Okay, good. Because on Friday I think we used minimum, but in this case we're just going to use maximum. So far so good. Can we keep going? Good, Lizzie?
Should we do the one side of it and press enter?
Perfect. Okay, so that little spider, you need to move it to the top, okay, where you think it is. I know it might be a little hard to see because it has the equation typed in up there, but you still have the ordered pairs at the bottom to kind of guide you. We want to move the spider to the top, and then we're going to hit the left arrow a few times. I don't care how many. And hit enter. We'll move the spider back to the top, but now hit the right arrow a few more times and hit enter. And the last question it wants is a guess. So you're going to go back to the top where you think it is and just hit enter. After you complete that process, the word maximum should pop up on your screen and we should have the exact ordered pair. Can we get those numbers? Do we need help? Okay, let's go ahead and write down that ordered pair. 6.19, comma 268.25. All right, so we use the calculator to help us with the calculation, if you will, but it's up to us to analyze it. What do these numbers mean in terms of this scenario? So if this is the maximum, this is the highest, how can we answer a question? What's the most amount of money that she had? Go to Carter.
260.
All right, so Becky had at most $268.25. So not only do we know how much she had, but we also know when that happened. Okay, a little after the 6th hour. And unfortunately, she kept losing from there. She had no self-control and she just kept going. Are we starting to get familiar with the calculator? Not as overwhelming as we probably initially thought. So far, so good? All right. So we're going to go ahead and move on to the next section. So we just got done with page 8. Page 9 through 12 was your homework. Okay, make sure that we keep up with that. And we're going to move on to the next section. We're going to review lines. Okay, I know this has probably been beaten into your brain since Algebra 1. We're just going to review some properties, some different calculations that we can have, some different forms of lines that we might see, but then we're eventually going to bring it back to the calculator, okay, and how we can utilize this a little bit more to help us with analysis. Okay, so this might seem a little redundant, but again, I need you to kind of help me understand what you already know. Slope-intercept form. What immediately pops into your brain? Y equals mx plus b. Okay, so what we're going to practice is writing a slope-intercept form equation. Let's go ahead and use the ordered pairs 4, negative 10, and then we'll use negative 12, 2. In order for us to write a slope-intercept form equation, we need to figure out an m, which stands for what? Slope, and the b, which stands for the y-intercept. Okay, so if we know 2 points, how can we figure out either of those characteristics? We're like mouthing it. I see everyone saying it, but no one wants to speak it. Yeah.
The slope would be y2 minus y1 over x2 minus x1.
Perfect. Okay. Now, with this slope equation, it doesn't matter which points you want to use first or second, as long as you're consistent all the way through. So for instance, if I choose 2 as my first y value, I need to subtract negative 10, which is the other y value. Notice how that would change to a plus because you're subtracting a negative. Now, if you start with 2 up top, you must start with negative 12 down below. You have to make sure you're consistent. Hello? Hey. After Labor Day would be fine. Not till September. Okay? Yes, that's fine. Yep, fine. Are we okay with that setup? Slope, right? All right, so we get 12 over negative 16, but that simplifies to negative 3 over 4. Okay? So we figured out the m. How can we figure out the b? Yeah.
You plug a point into the slope-intercept equation.
Okay.
And put in your slope as well.
Good. Does it matter which point?
No.
Nope, completely up to you. Do you have a preference? The first one? Okay, so if you want to choose the first point, the y value is negative 10. The m value that we just found is negative 3/4. The x value from the point we chose was 4. And notice how that leaves a b value for us to figure out. What about negative 3/4 times 4? Negative 3, right? The 4's cancel. Perfect. So it looks like our b value is negative 7. So let's go ahead and put all that together. Y equals negative 3/4 x minus 7. How can we graph that line now that we have an equation for it? You could have tried to graph the original 2 points, bless you, and draw a line through them, but I don't think our graph was big enough to fit those 2 points. You're on a roll. I'm going to let someone else try it out. How can we graph a slope-intercept form line? Good, Lizzie?
You can start by putting a cover that you're setting.
Okay, this is a y-intercept. Let's graph that point. 1, 2, 3, 4, 5, 6, 7. Okay. We need another point. You need 2 points to make a line. Where can we get the other one from? Let's go to Olivia.
Down 3 and over 4.
All right, we're going to use the slope. Rise over run. So down 3, right 4. That would be perfect, but unfortunately I don't have a graph there. Yes? Good, Blair?
So go up 3 and then the other direction.
You can work backwards. Yep, we can go up 3 and then left 4. 1, 2, 3, 4. All right, 2 points. You can draw your line. If you want to do rise over run again, 1, 2, 3, 1, 2, 3, 4. There we go. Okay to move on? We've seen that for like every year so far, right? Yeah. What about standard form? What might that look like? Yes?
AX plus BY equals C.
There we go. There is something special about the A, B, and C, though. Do we know anything about those numbers? Any characteristic? Yeah?
They always have to be whole.
They're whole numbers, okay? You usually won't see fractions in that standard form. They're usually whole numbers. So as an example, let's go ahead and write down 2x plus 3y equals 9. How would you graph that standard form equation? There's a few different ways, but I want to know what pops into your head first. Go, Blair.
Find the intercepts.
Find the intercepts. How would you do that?
You put 0 in for both variables.
I like
Not
it.
at the same time.
Perfect. Okay, that's actually how I do it. That's good. Does anyone feel like graphing that differently? Does anyone feel like solving for y and then graphing it this way? Probably. You can subtract the 2x, divide the 3, turn it into y-intercept form. I'm not telling you one way is better than the other. I just want to show you a shortcut. Blair's familiar with it. I'm not sure if anyone else is. Okay. Blair wants to find the intercepts, the x-intercept and the y-intercept. I kind of refer to this as a cover-up method, if you will. So for instance, if you were to cover up the 2x part, you're just left with 3y equals 9. If you were to solve for y, you'd get 3, right? Okay. Do the same thing for the 3y. Cover that one up, and if you were to solve for x, you would get 9 over 2. So that's the same as 4.5. Okay? By covering up those different variables, you are solving for the y-intercept and the x-intercept. Essentially, you're plugging in 0, because if you cover it up, it goes away. Plugging in 0 makes it disappear. So we can graph an x-intercept of 4.5 and a y-intercept of 3. Again, you only need 2 points to make a line. Have we seen that way before? Maybe? That's good. All right, last but not least, point slope form. Can we remember what it looks like? So far we had slope intercept form, standard form, we got one more. What do you think, Maggie? Yeah?
Y minus y1 equals m times x minus x1.
Wonderful. We always tend to forget this one, no? Yeah, okay. I'm telling you right now, if you guys eventually go into a calculus course, this form of a line is going to be your best friend. Ask anyone who's taking calculus, they'll probably say the same thing. At least I hope so. Okay? But this is going to be something that we use a lot in a calculus course. Maybe not necessarily this year, but definitely in calculus. So let's go ahead, just as an example, we'll use the same 2 ordered pairs from the slope-intercept form one that we did over here. And if we're using the same 2 points, that must mean we have the same slope. Now, when we did slope-intercept form, we had to do a little solving to help us figure out the b value, and then we were able to write the equation. Okay? If you have a slope and a point, okay, notice how we have two. You just need a point, meaning 1. If you have both of those pieces of information, you can go straight to the equation, not necessarily solving for something that you're missing. Okay? So since we have 2 points, we might be able to write 2 different equations. They're going to be exactly the same if you were to graph them, but they're going to look different when we write out the equations. So if we were to use this first ordered pair, we would need y minus the y value from the point. So if we subtract -10, that would change to a plus. We'll have the slope of 3, or -3/4, and then x minus the x value from the point that you choose. But we have another point, so some of you may have used that to help you write the equation. Can you guys try that real quick? What would the slope or the point slope form look like if you tried the -12, 2? Anybody want to give it a shot? Good, Julia?
1 minus 2 equals -3/4 times
X plus 12. Thumbs up? We did good? Okay. So we reviewed kind of the 3 different forms lines might look like. There are some different kind of properties of lines when we start analyzing maybe multiple lines together. For instance, if we have parallel and perpendicular lines. Can we discuss perhaps how we know whether lines are parallel or perpendicular to each other? Whether they look like this or they look like this? Is there some relationship I hope we're familiar with? What do you think, Travis?
If they have the same slope, they're parallel, but if they have opposite reciprocals and slopes, then they're perpendicular.
All right, so parallel lines have the same slope. Perpendicular lines, what'd you say it was? Go ahead.
Opposite reciprocals.
Opposite and reciprocal. All right, so let's check out our example here. Write the equation of a line that is perpendicular to this one and contains the point 4, 5. Okay, so we know we have to go through this particular point. Let's see if we can kind of calculate, though, this perpendicular, opposite, reciprocal, I forgot to write in the word slope. Okay, so what's the slope of this beginning line that we have? Go to Elsie, yeah. -2/3. Okay, so we're starting with a slope of -2/3. So then the perpendicular slope would be what? Can we figure out the opposite reciprocal? Good, Maggie, yeah. 3/2, good. Opposite, so if it's negative, you make it positive, and then reciprocal, you got to flip it. Okay, so our perpendicular slope is 3/2. How do you want to go about writing an equation that has this slope and goes through this point? We have some options at the top. We talked about 3 different ways we might be able to write an equation. I'm not saying there's one right way, because essentially you have 3. How do you want to go about doing that? What do you think? Yeah.
Slope intercept.
You want to do that one? Okay. So let's see. This point, the y value is 5. The slope is 3/2. The x value is 4. So we got to figure out the b value. 3/2 times 4? 6. So b is -1. Okay. So y equals 3 over 2x minus 1. I like it. So Matt chose to do slope-intercept form, had to calculate a little bit, but he still found a good equation. Anybody else want to try something different? Can we tackle either standard form or point slope form with the information we have? Blair, you have an idea? Point slope. Do we know a point? 4/5, right? Do we know a slope? 3 over 2, yes. So we should be able to use that one. Let's go ahead and write that out. We might have y minus the y value from the point equals our slope times x minus the x value from the point. There's a whole another equation you could have written. Notice how the directions didn't specify slope-intercept form, point-slope form, anything like that. Now, if you chose the point-slope form, there was no calculation necessary because you had the information you needed. Although most of you might have chose slope-intercept like Matt did, because that's what we're probably more familiar with. I'm just trying to open up or broaden your horizons because there are different ways to do things. Bless you, some might be easier than others, okay? How are we doing so far? Pretty good? Okay, that's our review of lines. Tomorrow we're going to talk about regression, how we're going to use the calculator to help us figure out equations of lines a little bit easier, especially when we have a whole plethora of information to consider. Okay, so if you have your own calculator, make sure you bring it definitely tomorrow. Okay? So we'll stop there for today.